Assalamualaikum. My name is Amiraka binti Abraza. So today I would like to explain about my project with the title of floating photovoltaic power prediction by using adaptive monofazing inverter system or Anfis. So the problem statement of this project is first, if we use the conventional energy, it will produce a great emission of greenhouse gases that will cause air pollution. So the second one is Malaysia as a natural tropical climate country has the average daily solar radiation and abundant sunshine with the value of as stated on the screen. So the third one is weak power rating will not result in same power output at the real condition. So the last one is complex and many steps required for calculation. So we can use Anfis to is the method of calculation. So this is the objective of my project, which is the first one to predict our output by using computation method to develop the Anfis configuration, and the last one is to evaluate the performance developed by Anfis. The scopes of this project is a series of parameters, which is ambient temperature, rating of PV panel, number of PV panels, and also solar radiance, in order to predict power output. The area selected for this project is the CG3 at my own university, which is located in Malaysia, to install the floating solar panels. And the ambient temperature, PV rating, and also solar radiance will be used to predict the Anfis configuration. So this is the methodology. So this is the PV panel that I have chosen by based on my research. The PV panels is PV with the 250 watt power rating. It is a Mitsubishi of type with the monocrystalline and high efficiency, proprietary cells, and also anti-reflection cuts. This kind of PV panel also has lead-free solder to protect health and the environment. So for the first method, which is compression method, I use three main formula, which is to find the module temperature at real operating condition, which is the cell. And next to the, I must calculate the rating factors of power due to cell temperature effect. And the last one, to calculate the power output for real operating condition. For Anfis configuration, I must insert the input parameters, which is PV rating, and the temperature, and also solar irradiance, with the targeted power output. All the data must be categorized by 70% of training data and also 30% of test data. The iteration or import must be set to 100. Root mean square error or RMSE can be find from the Anfis configuration, which it can determine the accuracy of the predicted values. So this is the results from a project based on my calculation. 50% of the total area of SHG will be used for this project. So it was expected to use 3,652 modules for the floating PV system, including the gaps between the arrays. So example of the simple floating PV outline can be seen from the picture. So this is the results for the computation method, where I have collected data from January till November 2021. So as we can see, the power output for January is the highest, which is 356.48 kilowatt, followed by August. So as you can see, the temperature was not determined the higher power output, since January has lower average temperature than February, March, and also April, but it has the most highest power output for as a whole. So this is why we must calculate the power output before we install the PV system. So this is the visualized data in graph for the prediction for output based on the monthly. So this is the result for Anfis configuration, where I use triangular function for the review of Anfis configuration. So this is the comparison between training data, which is computation method, and also FIS output. As you can see, the training data is in the black circle, while FIS output is in red star. So the comparison between both data, which is RMSE, produced 0.00032. So it is very low, and making the accuracy of the Anfis is higher than we expected. So this is the comparison in the tabulate data. So the value of both method is also, as you can see, was almost same, which makes the accuracy of Anfis is so high and the performance is so great. The performance of Anfis is great. So for the conclusion for my project, the PV model system depends on the environmental factors and also the rating factors of the PV panel. The actual power output will not be the same as the data sheet of the PV module. The highest power output, as it was stated before, is on January and also followed by August. The Anfis tool's robustness and speed was proved due to its calculation speed and accuracy. So my recommendation for the future works of this project, the prediction of power output can be implemented through various deep learning methods such as long short-term memory and also recurrent neural networks. The scopes of the project also can be expanded in terms of factors that affect the power output by considering inverter efficiencies, angle of the module, and also cable of thickness. So this is my current achievement for this project. And this project also has been published through International Journal of Scientific Research and Engineering Development, IGSRED. I think that's all for my explanation. Thank you. Assalamualaikum warahmatullahi wabarakatuh. My name is Amiralka binti Abrazak, and I will do the simulation for Anfis power output prediction for photovoltaic system. Okay, for the first thing, first we must have the desired parameters. And in my project, I use solar irradiation for the third input, ambient temperature for the second input, and the first input is for the PV rating. So we must divide the 70% from the whole data into data tree and another 30% into the data test. Data test. So when we generate the FIS into this data, we can get the rule viewer like this, and then this rule viewer by using the membership function of triangular managed to get the almost accurate power output, same as the output from computational method. So as we can see, when we enter the all three inputs parameters in the row viewer, we managed to get 104 watt per hour for 104 watt for the power output, same as the almost the same as the power output like computational method. So for another thing is to test the accuracy of the result, we can try to test the training data with the FIS output. So we can get this kind of graph which shows that the data for both training data and FIS output are almost the same. And the root mean square error or the average error for both data is between the value of 0.00032, which is the error, the produced error was a very lower in percentage, and this shows that Anfis configuration is in a great performance with higher accuracy. So I think that's all for my presentation. Thank you.